Let us look at question number 36, students. In the following reaction sequence, so we have been given a substrate which is allowed to undergo the given sequence of reaction to form the major product as C. The examiner seems to be interested in the number of stereoisomers which are formed in the product mixture. So if we talk about the first reaction, which is the hydroboration deboration, so this will lead to the addition of water in an anti-Markovnikov fashion without any rearrangement. So if we talk about the compound A which is formed, we're going to have the formation of this structure. And now this is allowed to react with H plus heat. So the H plus will attack this alcohol and convert it into a good leaving group, leading to the generation of a carbocation. The carbocation thus formed can undergo ring expansion. So electron rich group will have more tendency of migration. So the shifting will take place according to this. So this will lead to the formation of a 6-membered ring now. So if we talk about the carbocation, it will be formed at this position. So this will now undergo deprotonation upon heating and lead to the formation of an alkene indicated by this structure. Now when this is allowed to react with Br2CCl4, so the Br2CCl4 leads to the anti-addition of Br2, and we are going to have the formation of this structure along with the formation of this structure. Okay. So there will be a total of 2 stereoisomers formed in the product mixture. So if you look at the options which are given to us, we can clearly see that we have to select the first option as the correct answer to question number 36. Let us look at the next question. Question number 37. In the given reaction sequence, so we have a diene and a dienophile along with, this is the diol-alder reaction. So this will lead to the formation of a compound in this fashion. So this is the product A which is formed. Now this is allowed to react with O3Zn, which is the reductive ozonolysis. The O3Zn is going to break and convert this bond into corresponding carbonyl compounds. So we are going to have the formation of this structure. Now it is subjected to aldol conditions. So this will react with OH minus in presence of heat. So we can extract any alpha hydrogen. There are 4 alpha hydrogen in this case, and all of them are acidic. So we can remove any alpha hydrogen, generate the carbanion, and make an attack at the other carbonyl group. So this will lead to the expansion of one ring, whereas the contraction of the other ring. So earlier we had 2 6-membered rings. Now we have a 7-membered along with a 5-membered ring. And if we talk about the location of the double bond O and the OH group, we can see that the double bond O shall be over here, whereas the OH group shall be here. So we have a beta hydroxy ketone, and when this is heated, the beta hydroxy ketone will undergo dehydration to give us alpha beta unsaturated carbonyl compound. So this is the compound C which is formed at the end. And if we look at the options which are given to us, we can clearly see that we have to select the third option as the correct answer to this question. Let us look at the next question. Question number 38. So we have a reaction sequence, and during the course of this reaction sequence, compound A, B and C are formed, and the examiner seems to be interested in the structures of these compounds A, B and C. So if we talk about the compound A, the benzene diazinyl chloride is allowed to react with hot water, so it will lead to the formation of phenol. So the compound A formed is phenol. We can eliminate option 3 and 4 now. If we talk about the conversion of A to B, we have C double bond OCl OCH3 in the presence of OH minus. So this OH minus is going to extract the acidic hydrogen of phenol, will convert it into the phenoxide ion, and this phenoxide ion will now attack the carbonyl carbon and make the Cl group leave, as it is a better leaving group. So we are going to have the formation of PHOCO OCH3, and now this is allowed to react with Br2 in presence of FeBr3. This will cause bromination in the ring, so it is an electrophilic aromatic substitution reaction. So we're going to have the formation of this structure, with the bromination taking place at the para position as major, as the group present is bulky, so it won't give the ortho substituted product as major because of steric reasons. Okay, so if we now look at the two options remaining, we can clearly see that we have to select the first option as the correct answer to this question. Let us look at the next question. Question number 39. Identify the end product, which is also the major product in the following sequence of reaction. So we have the structure reacting with MeO minus in presence of MEOH. So students, this reagent set will lead to E2 elimination in this case, as the cyclic substances, they undergo elimination quite easily. So there will be a bimolecular elimination without any rearrangement of cation. So this will be formed as the major product X, and when this is allowed to react with Bayer's reagent, which is the cold basic KMnO4. Okay, so this will lead to syn hydroxylation of the ring, and when this is further subjected to oxidation using HiO4, the HiO4 will convert this vicinal diol into corresponding carbonyl compounds by breaking this bond. So we're going to have the formation of this structure. So this is the major product Z, which is formed at the end of the above reaction sequence. And if we look at the options which are given to us, we can clearly see that we have to select the first option as the correct answer. Let us look at the next question. Question number 40. So we have been given a reaction sequence, and the examiner seems to be interested in the major product D, which is formed at the end of the reaction sequence. So we have been given aniline. It is allowed to react with NaNO2HCl. So this will lead to the formation of diazonium chloride. So we have PHN2 plus Cl minus. This is allowed to react with CuCN in presence of heat. So this will lead to the formation of PHCN. This is allowed to undergo hydrolysis in presence of heat. So this will lead to the formation of benzoic acid. And when this benzoic acid is allowed to react with CH2N2 heat, so this CH2N2 heat is going to generate carbene CH2, and this carbene reacts with the carboxylic acids to give us methyl esters. So we are going to have the formation of PHCOOCH3. So the carbene can insert into this OH bond and lead to the formation of ester. So if you look at the options which are given to us, we can clearly see that we have to select the first option as the correct answer. Let us look at the next question.